So topic 3, free response, topic 3. Again, on this one, 1 through 3 are what's assigned. Okay, 4, 5, and 6 are on the back. If you want more practice, they're there. Answers are posted, but all I need to see is 1 through 3. I would call your attention to, look at where these problems come from and how frequently they appear. 2018, 2015, 2014, 2013, 2010, 2009. This is a very, very popular thing to put on the calculator part of free response. I'm not going to guarantee it because you never know, but very frequent that this type of problem shows up. And here's the summary of the whole thing. The integral of the rate, if you integrate the rate, you get a change in the amount. So amount at time 2 minus amount at time 1. And a lot of times they give you a calculator because they're going to give you some weird function that no way you could do that by hand, but you got a calculator and he can do the integral. He can do the dirty work for you. So let's do number 1. By the way, I definitely want to start seeing the free response on a separate sheet. Most of you did that, but not everybody. So for free response ones, I want to see those on a separate sheet. That way you can show your work and not be all squunched up in there. All right, so people enter a line for an escalator at a rate. So already I'm thinking the integral of the rate equals the change in the number of people. I made up P. I don't know, they maybe give me a different variable for that. But if I integrate rate, I'm going to get the change in the number of people. So weird function from 0 to 300, r equals 0 at t greater than 300. So what does r equals 0 mean? People enter a line at a rate of 0. So how many people are entering the line? Yeah, nobody. There might still be people in the line. So there might be 500 people in line at time 300, but nobody's adding to the rate is 0, so they're not changing. The number of people in line isn't changing. All right, R is measured in people per second. T is measured in seconds. As people get on the escalator, they exit the line. Oh, I need to be careful here. At a constant rate. So I guess E of T is 0.7 people per second. So can it be negative or should it be negative? It depends on how you want to set up the problem. You either have to have an overall rate of R minus E, which is not negative, or if you want to call it negative, then you'd say R plus E. So you could do it either way. If it makes sense to call it negative, I'm not going to call it negative, but I'm okay if you do, because that does make sense. There are 20 people in the line at time 0. You know what? I'm going to adjust my equation over here. To include R is people getting in line, E is people exiting the line or getting on the escalator. There are 20 people in line at time 0. So that means P of 0 equals 20. So that's going to help me when that's one of the points I know.
Can I ask a question?
Mm-hmm.
Why is the, I guess, okay, never mind. That's just the example. I was just wondering why it was 1 to 2. That's an example.
That's just the example, yeah. Maybe I probably should have just said A to B. That might have been a better way to phrase that. Okay, I think this makes sense. So the people arriving to get on the escalator, that varies with some crazy function. But the people exiting the line to get on the escalator, like that's a constant thing, like because the escalator is going at a constant velocity, so 0.7 person gets on every second. That, I don't know, this problem sort of starts to make sense, maybe. How many people enter the line? How many people enter the line? So not exiting, just enter the line during the time interval 0 to 300. So how can I find that out? I don't care about people exiting. I only care about people entering. How many people? Take the integral of the rate from what to what? 0 to 300. Because I don't care about how many people exited. I'm just counting this change in the people that got in line. And that's all the work you have to show for that one, because all those variables are defined. So now you can just go to your calculator. Oh, if you're borrowing one of mine, you may be in all sorts of weird things, because pre-cal's doing crazy things right now. I'm going to go ahead and put this in for R, assuming that I may have to do other stuff with it. So I'm going to put R in for Y1. That way, I mean, there's 3 more parts to this problem, so I can just use Y1 from now on. X divided by 100 cubed. 1 minus x over 300 to the 7th. Lovely. I guess if I wanted to go to the window, I'd go 0 to 300. But I don't even know that I care about the window right now. Because all I really want to do is integrate 0 to 300 of y1 dx. And again, like, who knows? Like, I don't even know that we could, I guess we could do that by hand, but we don't want to do that by hand. 270 people enter the line. The other big thing about these rate problems is they almost always have a rate of stuff being added and a rate of stuff being taken away. There's snow falling and snow melting. There's like a rain catcher, so it rains at a certain rate, but it drains off at a certain rate. People get in line, people get out of line. Like, almost all of these problems have stuff adding and stuff being taken away. And so you have to read the question carefully to know which rate to use, or both rates. During the time interval 0 to 300, there are always people in line for the escalator. Okay, I think that's thrown in there just to know that this never goes like negative, because then how would you keep up with negative people? That wouldn't really make sense. So we don't have to worry about dipping into the negatives. How many people are in line at time 300? Well, I think if I integrate from 0 to 300 of r minus e, and I defined what e is, so I can use e now that I defined what it is. If you just want to stick 0.7 in there, that would be fine too. That would be p of 300 minus p of 0. But they told me that there were, they told me that at time 0 there were 20 people in line. So 20 plus this ugly integral. 20 plus see if I can kind of cheat the system here and make my calculator life a little bit easier. Y1 minus 0.7. Is 80. There's another way to do that you could have found the total number of people that left the line. That would be easier because that would just be 300 times 0.7. So 210 people left the line. So you started with 20. We already know that we added 270 and we subtracted 210. And that got us 80. So a couple different ways to work part B. Part C. For t greater than 300, so greater than 300, nobody's entering the line anymore. So at 300, we already know that there's 80, and now they're just getting on the escalator. Like nobody's getting in line. We're just trying to clear the escalator or clear the line. What is the first time that there are no people in line for the escalator? So let's see, it starts at 80, and some of this you might just kind of figure out, like how many people are leaving the line per second? 0.7. So we start at 80, and we take away 0.7. I guess that should be t, but if you used x, it would be fine. Someone asked one of the chief grader people, if a student switches t and x, because you guys do this all the time, and apparently other students do it as well. Do they take off for that? And the grader said, no. What you do, what he tells grader is to tilt your head a little bit, and it kind of looks like a T, so it's right, and keep going. So yes, they're hard on some things, and other things are like, look, you know what's going on. You switched an X and a T, no big deal. It's still a T, right? So let's see, that would be 80 divided by 0.7. So T, or X, equals 114 point, always 3 decimals unless it says otherwise, 286 seconds. What is the first time that there are no people in line for the escalator? Okay, so 114 seconds, so 2 minutes. That's not too bad. So if you're the last guy in line, you got to wait 2 minutes. I mean, I'm thinking like this is like at, when you're leaving a concert or you're leaving the rodeo or something, and there's a gazillion people, and you got to wait for the escalator. But you've left a sports arena after the game, and you had to wait for the escalator? No. Not 2 minutes later. Part D. Okay, so most of that was okay. I don't know what the point split is, but I'm going to guess that it's 2, 2, 2, and 3 because D looks harder. But hey, if you get 6 of 9, then you're looking at a 4 or 5 the whole way through. So let's give D a try, even though, who knows, this may be something crazy, but maybe we can get something out of it. Okay, so back to 0 to 300. At what time t is the number of people in line a minimum? Okay, well, we said the number of people in line. It started at 20, and we would add from 0 to t, r of t minus e of t, or plus e of t if e of t is negative, or you can just go minus 0.7. To the nearest whole number, find the number of people in line at this time, justify your answer. People in line a minimum. Okay, how do I find minimums? What's true at a minimum? Slope is 0. So let's find P prime. So I need to take a derivative of all of this stuff. Derivative of 20 is 0. How about the derivative of the integral? The derivative of the integral. That's just r of t minus 0.7. We want to know when that's 0. So we'll use a calculator. I mean, you can even just say that, like, I'm going to use the calculator. Like, hey, grader, you know how to plug that in the calculator. That's what I'm going to do. I think r of t is already in there. But I need to stick a minus 0.7 there at the end. Although that's kind of dangerous. Maybe I want to just make it equal 0.7 and then get their intersection. I need to go 0 to 300. My y min and y max don't need to be that big. Ooh, there's 2 zeros. I bet one's a min and one's a max. I don't like this way I did this. I'm going to make it minus 0.7 because that will be the actual derivative. And then I can use increasing, or whether it goes positive to negative, negative to positive. So I'm looking at a graph of P prime. In fact, I may need to say this. P prime is a min, or no, P is a min when P prime changes. So what am I looking for? Changes negative to positive or positive to negative? If I want a minimum. Negative to positive. And I'm looking at a graph of P prime. It changes negative to positive right there. So let's go find where there is. So at 33.013. At what time, okay, got it, to the nearest whole number, find the number of people in line at this time. So I need to find P at 33.013. So that's 20 plus the integral from 0 to 33.013. R of t minus 0.7 dt. Yuck. But I have a calculator. I'm also going to save that. Oops. Well, I need to be accurate to 3 decimals, so shoot. Well, I'll use 33.013 and hope that that's good enough, because I'm almost out of time. I changed, y1 is now r minus 0.7, so be careful, but I can use that now because I changed what y1 is. And it said to the nearest person. Oh, so since it's to the nearest person, I'm fine with the rounding there, so 4 people. All right. Again, that last one's hard, but hopefully you can get all the ones before that, and then maybe you eke out a few points on that last one. So try 2 and 3. We'll go over those tomorrow, and then hopefully you're done. You still got a video to watch, video number 2. Again, be peeking ahead, be planning ahead, get all this stuff out of the way so that your weekend is completely free.